The first one is in degrees, just because it's nice after, like, now we're really used to working in radians, but it's kind of nice once in a while to go back and do it in degrees, just to keep that, like, think about how they're the same, right? Two different units, but measuring the same kind of thing. So we're going to do the first one in degrees. And how would I get started? Again, this is from grade 11, but if you don't really remember it, and also, this is actually a question very much like the ones we've already done in this course, in the previous unit, and a little bit in this unit. It's just disguised a little bit. So we just need to work out the disguise, and then we'll be good. So what am I going to do here? Anybody know?
Send everything except the x on the one side?
Yeah, we're going to move everything. We're going to just isolate the cos x part. So divide both sides by 3. I get cos x plus 2 is 7 over 3. And then I'm going to subtract 2 cos of x equals 7 over 3 minus 6 over 3, right? That's 2. And cos of x equals 1/3. Does that make sense? What do I do now? Sure, go ahead.
I forget what it's called, but you flip the cos over and it becomes a cos to the -1.
Yeah, so the inverse of cos, or arc cos sometimes you call it. You basically use your calculator to find out, what are we actually finding here? The related angle. Make sure I'm in radians here, because, yep, okay. Oh, thank you. I just said, make sure I'm in radians here, and this question is supposed to be in degrees. Oh my gosh. Very good. Okay, so shift cos of 1 divided by 3. Oh, I'm going to leave that answer. What was it? Shoot. Yeah, good. I'm just gonna do this because it'll give us an interesting talking point here. Okay, so this actually works out to 70.5 degrees. There's my related angle. So in degrees, it's easy to see which quadrant that's in. Well, it's going to be quadrant 1 because it's a related angle, but it's easy to think about it that way. Whereas when we get a decimal like this, it's not as obvious that that's less than pi by 2. In this case, it may not matter that much, but it's interesting to think about that way. If you get decimals, it can be hard with radians. We're not as familiar with it. That being said, I go back. This is just like from last unit. I go back up to this step, and I think, so if the cos of x was 1/3, that's positive 1/3. Which quadrants is cosine positive in, right? We go right back to that type of solving from the previous unit. And so x will be in quadrant 1 and quadrant 4. And so usually we just kind of solve it 0.5 and 360 minus 70.5. So 289.5. You don't have to list the quadrants necessarily. You can if you want. In some cases, we will kind of do it separately. But I've got 2 answers. Take those answers. Now it's rounded, so that makes it a little bit tricky. But if I take those answers and sub them back into my original formula, I should be able to do a left side, right side check and make sure that they both work out. So they won't. If I do 3 times the cos of 289.5 plus 2, I should get about 7. Okay? I'm going to put my calculator back in radians mode now while I'm thinking about it. You won't be asked to do degree work on the test. It's just, like I said, nice to kind of go back and think about it one more time. Any questions about that? So this is what we call a linear trig equation. It's linear for reasons that you will see when we compare it to other types, which we'll do in a momentarily. Okay, I want you to try the next one. Notice we're working in radians now. How do I know the domain tells me that it's asking for the answer? Answer, tell me what I do first here. Why is it different from the last question? Yeah, so be careful of that. Anybody? We divided by 3 here because of the brackets, but in this case we're subtracting 3. And then what do I do? Let me do it first. 2 cos x. So 2 minus 3 is negative 1. Now I divide by 2. Very good. Okay, so hopefully people got this far. Cos of x equals negative 1/2. How many people got that already? So when you see that, what do you think? Cos of x equals negative 1/2. Nice. So it's negative. See how, like, because the first one, when it came out to be positive, sometimes we just, oh, that's positive. We don't think about it. But when it's negative, then we have to really like, oh, yeah, right. I'm supposed to always be thinking about this. So it's negative. So it's in quadrants 2 and 3. And what about 1/2? That should jump out at us. Yeah, that's an exact value, one of our special triangle values. Very good, right? So cos of pi over 3 gives you 1/2. So my related angle in this case is pi over 3. And quadrants 2 and 3, because it's negative, is x is 2 pi over 3 and 4 pi over 3. Okay? Something that came up, I'll remind you, for a few people in the last unit is we weren't differentiating carefully enough between when we found a related angle and when we didn't. You have to do this. When you're finding a related angle, always have the r. That's communication, but it's very important. Okay? If you said x equals pi by 3, that's not true in this case. It doesn't. These are the two answers for x. Pi by 3 is not one of them. So that's a related angle. Okay? So show it still even here with the r. Any questions about that one? Can try the next one. Something else to note, and we're on the first day, so it's not as big of a deal, but you will eventually should be able to tell if you can give exact answers or if you can't. And when you can do exact answers, you do it. So the instructions won't necessarily tell you the case. So on the first one, we couldn't do an exact answer, but in this one, because it was a third, that's not a special triangle ratio. But this one is, a half is. What else would be? 1 over root 2, root 3 over 2. Like those are the ones we can give exact values for. And at this point, you should be able to recognize them. Okay, go ahead, try the next one. Let me see. Awesome. So how are you going to solve this part? That's what I was thinking. Right. So, good. You don't recognize that though, do you? So, as you work, try to keep in mind the special results that we can get, like I just talked about. 1/2, root 3 over 2, those kinds of things. But 0 and 1 are in there as well. You would use a graph for this one. Can you share what you did here with the class? Like how would you describe that? Answer. How you got to sine x equals 1, just in general. Yeah. Yeah. Yeah, very good. Yeah. Can you do that? Thanks. How are we doing on this one? Some people look stuck. It's interesting. Blake, can you tell us how you got this one started?
You move the -3 over, so it's +3, so it's 1. And then you move the 3 sine over, so it's -3 sine, so then there's 1 sine.
Very good, thank you. It's so interesting how we changed up the question a tiny little bit, and that's enough to throw some people off, and that happens because we're going to do 3 or even 4 different kinds of questions. And they all start to look different. We do them in different ways, and then all of a sudden, like one question is written slightly differently, and we forget about the strategies you're supposed to use. So I'm going to show you all the strategies for every type, and every time you're going to use one of those. Like, don't make up your own, in other words, okay? So this works out to 3 sine x plus 1, and then I move the 3 sine x over. Like, in other words, we're still isolating for sine of x, okay? And when I subtract 3 sine of x from both sides, 3 minus 4 is just sine of x equals 1, and I get to this step. In that case, you could do it in one step, yeah. But now, how do I solve this? Yeah, this is just a graph, right? So where is sine x equal to +1? Pi by 2. And in this case, we're not doing a related angle or anything like that. It's in one cycle, right? We're only looking at that first cycle of the graph, so we got one answer, we're done. Sometimes we have 2 answers, sometimes we have 1 answers. Throughout the next few days, sometimes we'll have all different kinds of numbers of answers. 1, 2, 3, 4, you name it. Any questions about that? That's linear. Those are still all linear. All right, let's move on to Quadratic. What makes this quadratic? Destiny. This is a square. Quadratic. That's all there is to it. I'm just letting you get this copied down kind of thing. But then I think you want to watch. So if you're still copying, just pause for a second because you have a chance to get that down. So this is like sine of x all squared, right? That's what that notation means, just to remind you. And so then minus 2 sine of x minus 3 equals 0. And so that's like, if you were awesome at factoring in grade 10, and then even awesomer, that's not a word, but in grade 11, you probably were able to follow, but this can be a bit of a higher, like a bit of a harder part to it, but you were probably able to follow that what's in the brackets can be anything. I could put anything in those brackets, and the overall relationship isn't going to be like a parabola or a quadratic necessarily, but the expression is quadratic. So when we say this is a quadratic relationship, we're not saying if I graphed this, I would get a parabola. That's not what we're saying. It's still a trig function. But what I'm saying is I could put a to the fourth and a to the fourth in there, and I could factor that like a quadratic. I could put x plus 1 and x plus 1 in there and factor it like a quadratic. Those are the trickier ones. We do in grade 10, but they're the trickier ones. Right? You could put anything in those brackets. We happen to have a sine of x in there, but it's the same thing as x squared minus 2x minus 3 equals 0. Somebody remind the class how we solve quadratic equations. We were isolating for linear. Is it the same? You have to factor it. Why?
Because there's square.
Yeah, why else? In other words, how is factoring going to help us solve this?
You're going to get one x like on each, I don't think
Each bracket?
Yeah, each bracket.
Yeah, and?
The entire equation equals 0, so then one of those brackets has to equal 0.
The zero product property is what we're talking about here. I don't know if you remember that from grade 10 and grade 11. Very good, everybody. So when I have two things that multiply to 0, one or the other has to be 0. We cannot isolate here because the squared term and the linear term, sine x squared and sine x in this case, like we can't do anything to jam those together to isolate just for sine x. But if we factor, we can get them in two brackets but separate in such a way that we can set them both equal to 0. We're doing the same thing here. We're solving this just like you solve quadratic equations in grade 10. It is the same thing. Okay? It looks different. If you want to do this kind of stuff off to the side, to remind yourself you can, you could even say like, let sine of x equal a, and sub a in and do a squared minus 2a minus 3 and factor it. I would recommend trying to avoid that, but if you have to, especially for now, you can. Does anybody know how we factor this? And so what do we do? Very good. Multiply to negative 3 and add to negative 2. Do you know what those two numbers are? So I'm going to do this. Watch, negative 3 and positive 2. Positive 1, of course. And then what do I put in the front of the bracket? Sine of x. Sine of x. Therefore, sine of x minus 3 equals 0, and sine of x plus 1 equals 0. So in this case, sine of x equals 3. And that's obvious what the answer to that one is, right? Anybody, do we know? What? We don't? What's it, John? Not possible. Thank you. Very good. That can fool us. Not possible. And that will happen fairly often. That could even happen in the linear ones. If it was like a trick question where you rearrange and you do something, you get sine of x equals something bigger than 1 or smaller than -1, the sign graph never gets to those. It only goes from +1 to -1. So that's the range that our answers can be in. Okay? So this is not, what is going on? Not possible. However, we do have an answer over here. Sine of x equals -1. So x equals, and from the graph, nice, 3 pi over 2. So in this case, we only got one answer. Let's try another one. What do we notice about this question that's different? Nice. It's a tricky trinomial. Yeah. What else? Yeah, reciprocal. There's two ways that you could do reciprocal. I could change them all to cosines now, or I could factor it the way that it is. Okay, so I'm going to factor it the way that it is, and then if another one comes up, maybe we'll do the other one the other way. You might see, if you look at the solutions online, you might see it that way, or you might see people doing it different ways. Both ways should work out the same. If for some, I don't think this would actually ever happen, but if for some reason in one case it was factorable, in the other case it wasn't, then maybe you choose the factorable way, but I think it's either both would factor or both wouldn't. How do I know if this is factorable? Because that's something we need to think about. Who remembers that from grade 11?
You can put like part of it, you can use part of the quadratic formula, and if you get a positive answer, then it will work out.
Do you remember what that's called?
I don't remember what it's called, but I remember like.
Yeah, very good. Do you remember? No. Discriminant. You may not have even heard of that. The discriminant. Have you heard that word before? That's too bad. We'll talk about it more in the next unit and as we go as well. But the discriminant is called b squared minus 4ac. What's b squared minus 4ac? It's part of the quadratic formula. It's the part under the square root sign. And it tells us the nature of the roots. So when you solve a quadratic, you can get sort of a few different cases. You can get two separate answers. And maybe you factored, or maybe you had to use a quadratic formula. You can get two answers that are the same, or which is one answer, or you can get no solutions. And the discriminant will tell us which of those things is going to happen. So what's B? There's a lot of review right now, I know, but B is 4. This 4 specifically, right? What's A? 4, also 4. And what's C? It's the other thing, -3. So do that on your calculator right now. B squared minus 4ac. So B squared, 4 squared, minus 4 times -3. Now the way I do it, like I think about the negatives, everybody's different, but I think about the negatives. And so B squared is 16. So I would go 16 plus 4 times 4 times 3. Like I would just do the negatives just to make sure I don't punch it in wrong on my calculator, you know. I've got one negative here and one negative here, so it's going to be a positive. So what do you get? 64. It's a perfect square. Therefore, this is factorable. It's factorable if the discriminant is a perfect square. Any perfect square, it's factorable. So B squared minus 4ac equals 64, therefore factorable. Okay? And if I got a positive non-perfect square, it's solvable but not factorable. If I get 0, that is a perfect square, so it's factorable, but it's actually you're gonna end up getting just one answer, like 2 answers that are the same. That's not as interesting because you still have to do it. But if you get a negative value, it's not solvable because you'd end up taking the negative of a square root, which we don't know how to do yet, right? Not really, we sort of do, but. Okay, so let's go ahead and factor it. So again, this is like 4x squared plus 4x minus 3. Quick, tricky trinomial review. Everybody's got different ways of doing this. The sort of shorter way that you might do now while you have practice, in the next couple of units, we're going to do a lot of factoring, so you'll get a lot of practice with this. But I take the coefficient of A, and I write down all the factors, and I flip one of them, and then take the coefficient of C, and I write them down. I don't have to flip on both sides. And then I call it a little dance across the line where you multiply, multiply, and add, multiply, multiply, and add, multiply, multiply, and add, and you're looking for the sum, right? So, but in this case, the fast way, if you need a review of this, talk to me again and we can go over it more slowly. Because one of them is prime, I like to put it in and then just kind of start in my head hunting for values. If you get a prime number, it's usually pretty easy. So I'm going to guess 2 and 2. Just a wild guess for whatever reason. I feel like that'll probably work. And so 2 times 3 is 6. 2 times 1 is 2. 6 minus 1 is 4, so that's going to work. And I want the 6 to be positive. So it ends up being 6x minus 2x, which gives me 4x. Now let's do it with our secants. So I get 2 secant x plus 3 times 2 secant x minus 1 equals 0. Therefore, secant x, you can do it the long way. I'll do it the long way, but you can jump straight to sort of the next step here if you want. One or the other or both of these equals 0. And again, in one case, maybe it will equal 0. In the other case, it won't. Like, we'll see. Who thinks they know what to do here? Asia?
Wouldn't cos x be 2, negative 2, and the other side is just 2?
Very good. So this is where now, if we didn't before, we switch it to cos that we can actually solve for. This one's not possible. And this one is possible. Quadrants 2 and 3, I'm going to get 2 solutions. We're not going to do it because I want to get to another example. I'll do it and I'll post it if you want to see the solution. I would encourage you to finish it, but that's something we've done a lot of, so hopefully you can get it. Not a special triangle, so you would have to do it in your calculator. Shift, cos, positive 2 over 3, right? Don't put negatives in your calculator, all that good stuff. Hopefully you can figure that one out. That's the wrong example. Let's do this one. If we have time, we'll go back and do the other one. This is a new type of question. So it's one that you eventually need to be able to identify it for what it is. And this is where people start to get confused. Which type of question am I solving right now? So it looks like we're going to solve it differently because it's not really linear, it's not really squared, it's not really quadratic, and there's like sine cos on this side and a 2 sine on that side. Oh, maybe I use an identity or something. Like people start doing all kinds of weird things. But what we're actually going to do is still isolate. So we're going to move, like a quadratic, we're going to move everything to one side. Okay? Folks, that is one of the strategies that we will almost always use. When it's linear and you can isolate for sine x or cos x or whatever, tan x, secant x, cosecant x, whatever it is, if there's only one of those terms and you can isolate, that's what you do. If there's any jumble of junk, you're moving everything to one side and setting it equal to 0. Don't ever think that you're not doing that. Don't ever think, oh, maybe I solved this one with graphs, or maybe I solved this one. So no. Maybe I try to balance both sides. No. It's not an identity. We move it all to one side. Okay? But what do we do here?
You can factor out sinus.
Very nice. Great insight. So this isn't a quadratic per se, but it's still a question that factoring and using the zero product property will work. So what does it look like if I factor out a sine x? Because there's a sine x in both terms. I get sine x times cos x plus 2 equals 0. Therefore, sine x equals 0 or cos x equals negative 2. So again, this is not possible. Okay? And sine x equals 0, when does that happen using the graph? This was on our quiz, I believe, at the very beginning of the year. And a lot of people got part marks, but not all of them. Pi and?
0 and 2 pi.
And 2 pi. There's 3 answers to this one. Just because sine starts at 0, goes through 0, and ends at 0, happens to hit it 3 times, is the only value, right? Happens to hit it 3 times in one cycle. So be careful of that. So x equals 0, pi, and 2 pi. Again, if you've seen it once, you try to remember, oh, this is that tricky one, there's 3 answers. Remember what I said. There could be no answers, there could be 1 answer, 2 answers, 3 answers, there could be 4. I mean, come up with questions where there are even more. Any questions about any of that? Don't copy this down. These are the questions that we've done so far, except I changed that one and I didn't change it down here. Look at all the different kinds of questions. How do you solve all the different types? That's just a linear. Look at it. Get familiar with it. It only has one thing in it, one cos x part. Even if this was squared, I could still isolate and would solve it that way because I can isolate. Even if it was cos squared x. We'll look at an example like that. Don't worry about it for now. But okay, what's this type? Oh, that's a quadratic. I factor it. What's this type? Oh, common factor. See how you look at the different types and try to identify the different kinds of questions. There's one where I can isolate. That's the one where I move the sine x over and move everything to the other side. This one's supposed to be the secants. And so it's, again, a quadratic. The only one we haven't looked at is this one. So we only have 5 minutes left, but let's take a look at it right now. How do I do this question? It's a mix of 2 of them. Again, how would you know how to solve it? By practicing and getting used to it. Some of the practice you've done with identities will really help. What I'll notice is I've got a sine squared, and a cos. I can't common factor. It's got a squared. I'm thinking like quadratic factoring, but I can't the way it is. And what else do we notice? The double angle is very different from single angles. So there's something going on here. Very nice. And what is the equation? Which one? Because cos 2x has 3 versions. 1 minus cosine. Why would that be the one we use? So 1 minus sine squared. What is the actual formula? Who knows it? So I'm going to take this. Good. And it's 1 minus 2 sine squared. We want to make sure we get the exact right formula. Very good. Good job, John. Good job, everybody. Plus 3 sine squared x plus 2 sine x equals 0. So I'm just going to rearrange things a little bit. 3 sine squared minus 2 sine squared is sine squared x plus 2 sine x plus 1 equals 0. So see how it worked out into one of those. But you need to be able to identify, that's one of the trickier parts. You need to be able to identify, when you just look at a question, I'm not going to tell you on the test, this is a linear, this is a quadratic, this is a common factoring. That's part of what you need to be able to do. And that's part of what makes this a really tricky unit. And then tomorrow, we'll add on a small twist that won't have that big of an impact. But then on Monday, or not Monday because it's Monday's a holiday? Yeah, wow, awesome. Tuesday, we'll add on something that will complicate it a little bit. So how would I solve this? We only got a couple of minutes. This is an easy one. Does anybody know what it is, Jason?
Sine x plus 1 squared.
Sine of x plus 1 squared equals 0, right? So it's sine x plus 1 times sine x plus 1. You do any way you factor it, you're going to get the same thing. So that means sine of x equals -1. We've already seen that. X is 3 pi over 2. In this case, we only got one answer, but like I said, they all work out in different ways. Any questions? This is tricky stuff, folks. Make sure you practice. Think about the different types. On the worksheet, they are like question. Oh, worksheet. So your homework tonight is questions 1 and 2. And then tomorrow is question 3, and then Tuesday it's question 4. But you'll notice that question 1 is like, there's your linear. And question 2 is, there's your quadratic. So they're split up on the sheet, but we need eventually, not yet, because we're just starting, but eventually to be better than that. And be able to tell for ourselves which is which. So tomorrow something a little bit new. Tuesday, more solving equations, but they look different. And then Wednesday and Thursday next week are 2 review days. And then test on Friday.